welcome to PB Garage.
And what are we doing today?
Powder coating.
Okay.
We're going to powder coat this part of it, and we're going to use silver.
Go ahead.
It scared me.
Well, yeah.
Oh, cool.
Okay guys, so I've cleaned this as best as I can. I've gotten all the corners, I've scrubbed it over and over and over again. I think all the grease is off of it. Now, because it's an aluminum part, Eastwood recommends that you do a preheat cycle on this part to dry out any greases or oils that are still in the pores of the material. And what that involves is just putting it in the oven for about 450 degrees for about 20 minutes, 25 minutes. Taking it out, go back to the sink, scrub it again to get all the grease and dirt that's come out of those pores, and then maybe do another cycle again. So I bought an oven from Kijiji. It's just a kitchen oven, nothing fancy, and I've converted it to use a PID controller, and this controller allows me to control the temperature profile over a period of time in a much more precise manner than I can with the stock or the standard controls. I intend to use this oven for powder coating and carbon fiber parts, and that's why I bought this PID controller. For powder coating, you don't really need that. You just, you want to get the oven to a certain temperature and hold it there. So a standard oven will do just fine, but just don't use your regular kitchen oven. That's not really a good idea. So I'm gonna throw this in, and then I'm gonna take it out and clean it again. Hey Alexa, announce dinner's ready.
Announcing.
Dinner's ready. Okay, so I cleaned this very well. I've gotten all the corners, I've scraped everything out. It's spotless, it's not going to get any cleaner. I also decided to powder coat these Diff output shafts, sand those down as well. I'll clean them, degrease them. I left the holes unprotected, so powder is going to get in there, but I'm going to chase these holes after the fact, so I'm not too worried about that. On the cover, I've used a mix of high temperature tape and tinfoil. That should keep powder out of the areas where I don't want the powder. I'm using Eastwood's dual voltage powder coating gun. It can do small and large parts. That's where you get the advantage of the dual voltage capability. I've got my air system set up for about 8 psi. And that's all there is to it really. In my booth here, I built this a few weeks ago, a month ago, whatever. I've got a fan mounted on top, which is just a old house fan that I had that I converted and bolted in here. I've 3D printed this switch box so that I can control the fan speeds. And I've mounted a filter underneath here, and that's just held in place with some 3D printed brackets. Nothing fancy. And then just some lights from Amazon, closet lights that are mounted on the side to give me a bit more illumination inside this box. Definitely gonna invest in some better mitts because I'm using my kitchen supplies right now, and I know I can do better. So you may have noticed that when I preheated this part to remove some of the greases off of it, the bearing shell for the diff fell out along with the shims. So I'm just gonna warm it back up, and then I'm gonna press this back in, and then I'm gonna flip it around and press the seal in, and I'll show you that in a second. So just a note here guys, when I was topping this one out with the screwdriver, I was not using the edge of the seal because I didn't want my screwdriver to scratch or score the bore where the seal is going to sit. So I drove from inside the lip here and just worked it on both sides, and it just popped right out. Okay guys, so I'm about ready to put this diff back together, but before I do so, I just want to go over a few things. The powder coating process went fairly well. The only thing I noticed was it was hard to get even coverage of powder into these deep recesses. They tend to build up on the flatter, more pronounced surfaces. So it's not as visually appealing in those areas, but for this part I'm not too concerned. I'm not going to go back and redo anything. Just on future parts I may look to improve in those areas. Same with the surface finish. So it's a bit dull, a bit matte, which is fine for these parts, but in the future I may look to use a clear coat to give it a bit more shine. So just a couple mechanical things before I get started putting it all back together. Check all your mating surfaces, the O-ring groove in here. Check the diff case. This is where the O-ring is going to sit. Just make sure it's not nicked, damaged, scratched, anything like that. The O-ring itself, I'm reusing my old one. It looks good. Not a bad idea to replace actually. You can probably get them pretty cheap, but run it through your fingers, make sure it's not nicked or damaged, bend it, make sure it's not dry rotted and doesn't crumple. For threaded holes, chase all your threaded holes. It's easy to do right now. Blow them out with compressed air once you're done. On the diff itself, inspect your bearings, make sure there's no pitting on the rollers, there's no pitting on the outer races, they're not excessively discolored, so that may happen if you had low fluid and they got really hot. The gear teeth, make sure the surface integrity is good on those. Again, just looking for pits or signs of excessive discoloration or uneven wear. Mine look good. I think everything's ready to go back together. So thanks for watching, guys. I'm gonna wrap this up by putting it all back together, and stay tuned for the next video. So yeah, you can see we're going to powder coat this part of it, and we're going to use silver. You want to do that?
Mm-hmm.
Go ahead.
We're going to powder coat this part of it, and we're going to use silver.
And that's what the video is going to look like.
Cool. Hi.
Hi. What are we doing?
See,
what do you want to say? What's your line?
welcome to PB Garage.
You going to help?
Yeah?
High five. Yeah.